Hello viewers, in today's session we are going to discuss another interesting problem from domain of functions, and in this class we are going to find out the domain of this function f of x, which is square root of cot inverse 2x minus 1 divided by 5 root 3 minus pi by 3, right? So here in order to find out the domain of this function, we'll make use of the principal value branch of cot inverse function, right? And from inverse trigonometric functions we know that cot inverse theta, it belongs to this interval that is 0 to pi, where this theta belongs to the set of real numbers, right? So here we'll make use of this concept to find out the domain of this function f of x. So here we have the real number line, and here we have 0 to pi, and this is an open interval. So here we have 0 and here we have pi, right? Okay, so now see, here we have a square root function. So the first condition to get the domain of this function is that this entire term which is inside the square root function should be greater than or equal to 0. So we must have cot inverse 2x minus 1 divided by 5 root 3 minus pi by 3 must be greater than or equal to 0. So this term has to be a positive, right? Because we cannot have a negative number inside the square root sign, because in that case the number becomes a complex number. But here we are dealing with only the real numbers. So now let us take this term, that is 2x minus 1 over 5 root 3 equal to theta, so that we have cot inverse theta minus pi by 3 is greater than or equal to 0. So now we can write cot inverse theta is greater than or equal to pi over 3. So taking minus pi by 3 to the right hand side. Now this inequality suggests that cot inverse theta should be greater than or equal to pi by 3. Now between 0 and pi we have here pi by 3. So now this pi by 3 splits this interval into two sub intervals, that is from 0 to pi by 3, and here we have pi by 3 to pi, right? And here we can now write cot inverse theta greater than or equal to pi by 3. So we have to consider only this interval, that is from pi by 3 to pi, right? And remember, cot inverse theta cannot go beyond pi. So we can now here modify this inequality by writing here cot inverse theta should be greater than or equal to pi by 3 but less than pi, right? So we have to consider only this interval. We cannot take this interval that is from 0 to pi by 3, because here uh, cot inverse theta is greater than pi by 3 or equal to pi by 3. So now we have to solve this inequality. So now let us take the cot of all these three quantities. So here we have cot pi by 3, and here we have cot inverse theta, and here we have cot pi, right? And we know that the cot function is a decreasing function, so the direction of the inequality it gets reversed, right? So here taking the cot of all these three quantities and reversing the direction of the inequalities, because cot function is a decreasing function, right? And from trigonometry we know that cot pi by 3 is cot 60 degrees, that is equal to 1 over root 3. So now here we have cot pi, and from the graph of cot theta, we can easily see that cot theta tends to minus infinity when theta tends to pi, right? So cot pi, it tends to minus infinity, right? Okay, so now cot pi by 3 is 1 over root 3, and here we have cot inverse theta, that is simply a theta, because we know that cot inverse theta is equal to theta, and here cot pi, it tends to minus infinity, right? So here we have minus infinity. So we can now write this inequality as theta greater than minus infinity and less than or equal to 1 over root 3. So now let us substitute the value of theta in this inequality. So we have minus infinity, then we have 2x minus 1 over 5 root 3, and here we have 1 over root 3. So now let us multiply throughout by 5 root 3. So multiplying negative infinity with 5 root 3, it gives minus infinity, and here 5 root 3 and 5 root 3 get cancelled, and here we have root 3 and root 3 get cancelled, so we have 5 times 1, that is 5. Now let us add 1 throughout. So adding 1 to minus infinity, it gives us minus infinity. Here 1 and minus 1 get cancelled, and here we have 5 plus 1, 6. Now let us divide throughout by 2. So dividing minus infinity with 2 will get simply minus infinity. Here 2 and 2 get cancelled, and here we have 3, right? So viewers, the domain of this function is given by this interval, that is x belonging to the interval minus infinity to 3, and here 3 is included, right? So here if we have the real number line, then here we have 3. So the domain of this function is from minus infinity to 3. So this is the domain of this function f of x, including this number x is equal to 3. So this is how by making use of these concepts, we can easily find out the domain of functions of these kinds. And here we must remember that when we have cot inverse theta greater than or equal to pi by 3, then we cannot take this interval, because from 0 to pi by 3, we have all the numbers which are less than pi by 3, right? So we have to take this interval, that is from pi by 3 to pi. Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this class we are going to find out the domain of this function f of x, that is equal to cos inverse, and here we have a logarithm of x minus square root of 2 to the base 2 minus half, right? So let us see how we can find out the domain of this function using the concept of principal value branch of inverse cosine function, right? So let us start. So here let us take this term as theta. So we can now take theta is equal to a logarithm of x minus square root of 2 to the base 2 minus half, so that this function it assumes the form cos inverse theta. Now from inverse trigonometric functions, we know that cosine inverse theta, it belongs to this closed interval 0 to pi. That is, the range of cos inverse theta is from 0 to pi, provided this theta, it belongs to this interval minus 1 to 1. That is, theta is greater than or equal to minus 1 but less than or equal to plus 1. So let us make use of this inequality, right? So here we have this expression equal to theta. So let us substitute this value of theta in this inequality. So we have now minus 1. Here we have log of uh, x minus root 2 to the base 2 minus half, and here we have 1, that is plus 1, right? So let us solve this inequality. So here we have minus half. So let us add half to this inequality throughout. So we have minus 1 plus half, and here we have log x minus root 2 to the base 2, and here half and minus half get cancelled, and here we have 1 plus half. So minus 1 plus half is minus half, and here we have log x minus root 2, and here we have 2 base 2, and this is 3 over 2, right? So now to move further, here we have log function, that is log of x minus root 2 to the base 2, and here the base 2 is greater than 1, and we know that from the theory of functions, that is the function log of say x to the base a, where this a is greater than 1, then this function is an increasing function, right? So here what we will do, we'll get rid of this log function by raising these three quantities to the power of 2, right? So raising these three quantities to the power of 2, we have 2 raised to minus half, right? And here we have 2 raised to a log of x minus root 2 to the base 2, and here we have 2 raised to 3 over 2. So now let us see this expression. Now this expression is of this form, that is a raised to log of say p to the base a. Then we know that the value of this expression is equal to p. So we have now 2 raised to minus half is 1 over square root of 2, and here we have simply x minus root 2, because the value of a is 2, and the value of p is x minus square root of 2, and here 2 raised to 3 over 2 is 2 root 2, because we can write 2 raised to 3 over 2 as 2 raised to 1 plus half, that is 2 raised to 1, and 2 raised to half, that is 2 root 2. So now we have this inequality. So let us add plus square root of 2. So adding root 2 throughout, we have 1 over root 2 plus root 2, and here we have x, simply x, because root 2 and minus root 2 get cancelled, and here we have 2 root 2 plus root 2. So now simplifying this, we have 1 plus 2 over root 2. Here we have x, and here we have 1 root 2. So this is 2 plus 1, 3 root 2. And this is 3 over root 2. And this is x, and here we have 3 root 2. So now here rationalizing the denominator, we have 3 root 2 over 2, and here we have x and 3 root 2. So the domain of this function is given by this inequality, that is x belonging to this interval 3 root 2 over 2 comma 3 root 2, and remember here both the extreme points are also included, right? So the valid values of x for which this function f of x is defined is given by this closed interval 3 root 2 over 2 comma 3 times square root of 2. So this is how, by making use of the concept of inverse trigonometric functions and this inequality, we can easily find out the domain of functions of these kinds.